Okay, let's continue with some examples for trinomials of this form with a leading coefficient other than 1. And we're going to use the wow method for all of these from here on. Any method you use is perfectly fine as long as you can factor. So factor, it starts with a 2. I want to see if the 2 can be pulled out as a GCF, and I can't because the 11 is not divisible by 2. So I take this 2 and I move it up here and I multiply it by the 12. That's going to make it an x squared plus 11x plus 24. Now I focus on this new problem. I'm going to have x and x to get the x squared. I want two numbers that multiply to give me 24 and add to give me 11. And it looks like positive 3 and positive 8 will do. But now I moved up that 2 and multiplied by it, so I'm going to divide both terms by 2. And once I do that, the second one reduces x plus 4. The first one doesn't reduce, so I just move that guy back up and I get 2x plus 3, and I am done with that one. Again, to check your work, always distribute it back and make sure you get the original trinomial. Next one, again, I'm going to check to see if I can pull out a GCF first. I can't, so I'm going to move the 10 up and multiply it with the negative 2. That gives me this new problem that now has a leading coefficient 1. I'm going to factor y, and two numbers that multiply to negative 20 and add to a positive 1 because the coefficient is 1. Looks like 4 and 5 work, with 5 the bigger one being positive because of the positive 1 and 4 being negative. Again, don't forget that you had moved up the 10 and multiplied by 10, so now we're going to divide both of them by 10 and do any reducing that needs to be done. It looks like they both reduce. Y plus, they're both divisible by 5, so that becomes 1/2. And this one, they're both divisible by 2, becomes 2/5, it looks like. Now I move the 2 up and the 5 up, and I have 2y plus 1 and 2y, or 5y, I'm sorry, because I'm moving the 5 up. 5y minus 2. And again, if I multiply that out, I get the 10y squared, the negative 4y, and the positive 5y to give me the 1y, and then the negative 2 at the end. Okay, next one. Again, my first check is to see if I can pull out a GCF, greatest common factor. I can't, so I move the 12 up and multiply it with the 6. That's going to give me the r squared minus 17r plus, it looks like, a 72. Now with this new problem, I need two numbers that multiply to a positive 72 and add to a negative 17. So I will have r and r multiplied. And if the numbers are big, just make yourself a little chart and go through all the factors of that number. So for example, 72 times 1 is 2 of the factors of 72. They both have to be negative to give me the positive 72 and the negative sum in the middle. And clearly that's not going to work. 72 is divisible by 2. That'll be 36 and 2, both of them being negative, to get a negative number in the middle. Clearly that's not going to work either if I add them up. Then I go through my list. Is 72 divisible by 3? Yeah, that's going to be 24 and 3, both of them being negative. Again, those guys are not going to multiply to give me, or add to give me negative 17. Then I say, well, is 72 divisible by 4? Yeah, it is, and it goes 18 times, so negative 18 and negative 4. Clearly those two don't add to give me what I need. Then I say, is 72 divisible by 5? And the answer is no. Is 72 divisible by 6? Yeah, that's going to go 12 times, both of them being negative. I still don't get the negative 17, but I'm pretty darn close because that gives me a negative 18 actually. Then I go on. Is 72 divisible by 7? No, it's not. Is 72 divisible by 8? Yeah, it is. So I have 9 and 8, both of them negative. That'll give me 72, and if I add them, they give me the negative 17 I need. So if your number is really big, just go through all the factors, divisible by 2, by 3, by 4, by 5, by 6, by 7, whatever it's divisible by, until you reach the number that works. So, or the numbers that work. -9 and -8 were the ones that gave me the -17. But remember, you had multiplied by a 12, so divide both of them by a 12. Now we're going to reduce. That's going to give me r minus, they're both divisible by 3/4. R minus, they're both divisible by 4, that's 2/3. Then I move the 4 up, the 3 up, and that's going to give me 4r minus 3 and 3r minus 2. Again, quick check, 12r squared minus 8r minus 9r, that's minus 17, and then a positive 6 for the last term. Okay, next trinomial to factor. It looks a little bit different because I have an x cubed, but I realized that my first check, remember, is GCF before I do anything else, and in this case I can pull out a 3, they all have a 3 in common, and also an x. So I pull that out, and I'm left with 2x squared minus 5x plus 3. Now I can go ahead and just focus on this guy and save this for later. I'm going to save the 3x for later to deal with. So 2x squared minus 5x plus 3. Again, I'm going to move the 2 up and multiply it with the 3 and make my new problem x squared minus 5x plus 6. Now I have a leading coefficient 1, which is easier. Product 6, sum -5, x and x. And it looks like both have to be negative, and -2 and -3 will work because it gives me the -5 I'm looking for. But you had multiplied by 2, so don't forget, go divide both of these guys by 2. It looks like the first binomial has reduction happening, x minus 1. This one doesn't reduce, so just move the guy back up, 2x minus 3. And then don't forget, you had saved the 3x, drop it back in the front, and this fully factors the original trinomial. Again, to check your work, you could multiply these guys out and then distribute the 3x. Or distribute the 3x in only one of them, and then multiply this binomial with the result. Let's go to part E. Again, things look a little bit different, but we have a GCF of 3 again, and it looks like an x squared this time. That's going to give me 10x squared plus just 1x minus 3. Now I'm going to go focus on this guy and save the 3x squared for later. So my trinomial to worry about is 10x squared plus 1x minus 3. Move the 10 up and multiply it by the -3, x squared plus x minus 30. Open up my binomials, two numbers that multiply to -30 and add to a positive 1. It looks like 5 and 6 are going to work, and 6 has to be positive to keep the sum positive, and 5 has to be negative. But remember, you multiplied by a 10, so now you're going to divide each of these by the 10 and do any reducing that may be done. These are both divisible by 2, so x plus 3/5 is what I'm going to get. These are both divisible by 5, so x minus 1/2. And then these guys go back up. So I have 5x plus 3, 2x minus 1, and this guy is going to drop back right in the front. And there's our fully factored version of this trinomial. Okay, last one to factor. Let's factor this trinomial. I checked to see if there's a GCF to be pulled out, and there isn't. So I moved the 10 upstairs and multiplied with the -2. So that's x squared plus 3x minus 20. Now that makes it a leading coefficient 1 problem, so x and x. I'm looking for two numbers that multiply to -20 and yet add to a positive 3. And if we go through our list, I want a product of -20 and a sum of positive 3. If we go through our list of all the possible factors of 20, 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5, and then 5 and 4, it's the same thing. It's not divisible by 6, not by 7, not by 8, not by 9. It is divisible by 10, but that gets me back to 10 times 2. So I've exhausted all my list, and in order for the product to be negative and the sum to be positive, all the bigger ones have to stay positive and the smaller ones are negative. Now when I add these guys, that doesn't work. That doesn't work. That doesn't work. I exhausted my entire list of factors. None of them work for me to be able to complete the two binomials. So if you come across something like that, then the answer is prime. In other words, it wasn't factorable. If some polynomial is not factorable, then the answer is prime. So keep that in mind, that it is possible that your polynomial may be prime and you won't be able to break it up.